We investigate mosquitoes in northern Patagonia, a cold and dry area. It is a transition area between the Andes Mountains and the Patagonian steppe. Winters are cold and wet, but summers are dry. Mosquitoes only breed in puddles near the river, jars and other debris that don't accumulate water in the summer because of the dry season. We are in a valley surrounded by mountains near the Cordillera de los Andes. Climatic characteristics of the region. Annual average temperature between 8 and 10 degrees. Annual average wind speed between 28 and 32 km per hour. Annual average total rainfall between 1,000 and 1,100 millimeters. Research questions. What differences in water quality and macroinvertebrates are there between the Chimewin River and puddles near the river that have mosquito larvae? Why do some puddles have no mosquitoes? Will other aquatic species of macroinvertebrates and vertebrates be found in puddles with mosquitoes? Sampling sites in puddles near the Chimewin River, with mosquitoes and without mosquitoes. Materials and methods. Sampling period from January to March 2020. We use the Globe Hydrosphere and Biosphere protocols, the Globe Observer, mosquito and land cover application. We sample in puddles and in the Chimewin River. We measure water quality, macroinvertebrates, mosquitoes, and land cover. We put mosquito traps with yeast baits and bead shells. We locate them in natural and urban areas. To know altimetry, we use Google Earth Pro and Open Altimetry. We downloaded the satellite images from WorldView. For statistical analysis, we use Statistica, Test T, and Cluster Analysis. Here you can see photos of environments, physical-chemical analysis, and identification of mosquitoes and other freshwater macroinvertebrates. These are the traps that we place in natural environments, near puddles with mosquitoes and in urban environments.
Resultados preliminares. Solo encontramos mosquitos en pocos charcos. Los charcos con mosquitos son cerrados, sin conexión con el río. Solo en el charco 5 encontramos larvas de mosquitos y otros macroinvertebrados que podrían ser posibles depredadores. Lamentablemente no pudimos continuar investigándolo porque en Argentina se declaró la cuarentena por el coronavirus y fue imposible salir. Aquí pueden ver los charcos con mosquitos. En general solo hay mosquitos y anfípodos en densidades similares. Solo encontramos mosquitos del género Culex, fácilmente identificables por la forma del sifón que tiene. Aquí pueden ver larvas, pupas y adultos. Las pupas las mantuvimos en condiciones de laboratorio hasta que emergieron los adultos para poder fotografiarlos. No encontramos mosquitos en ninguna de las trampas. Junín de los Andes está en un valle rodeado de montañas. Esta característica hace que existan numerosas pendientes que facilitan el escurrimiento del agua, reduciendo el tiempo de duración de los charcos. En los tres cortes se muestran las pendientes en los charcos con mosquitos. A la derecha se muestra la pendiente del río Chimewin con el tramo de los muestreos con mosquitos. Los datos del satélite ICESat-2 muestran con mayor precisión que Google Earth Pro la altimetría de la zona. Lamentablemente no hay datos específicos para los sitios de muestreo, pero se puede tener una idea de las pendientes en el área. En el gráfico inferior muestran la altura de los árboles. En su mayoría miden entre 5 y 20 metros. Solo unos pocos llegan a 25 o 28 metros. Las imágenes de temperaturas muestran que a lo largo del periodo de muestreo la temperatura de superficie fue disminuyendo, tanto de día como de noche. Las lluvias fueron muy escasas durante todo el periodo de muestreo. El gráfico muestra los registros históricos de los meses de enero a abril. Se observa que la escasez de lluvias durante el verano se ha mantenido casi igual, con pocas variaciones desde el año 2001 a la fecha. El NDVI muestra el escaso crecimiento de la vegetación y cómo se va reduciendo de enero a marzo. El límite entre la estepa y el bosque. La humedad del suelo muestra un comportamiento similar. En el mes de febrero, el suroeste de Junín de los Andes hubo algunas lluvias. Por eso aumentó la humedad del suelo. En marzo se observa una marcada disminución de la humedad del suelo.
The land cover results around the river were only dominated by two types of MUC with similar percentages. The land cover in the puddle highlights the presence of trees with a high percentage of shade that reduces evaporation and changes in temperature. There is also a high percentage of herbaceous cover. The water quality results between the puddles and the river have similar values in temperature, pH, and nitrates. Very significant differences were found in dissolved oxygen. In the puddles, the oxygen is very low. There were also significant differences in turbidity and alkalinity, which is higher in puddles than in the river. Although the conductivity values are higher in puddles, these differences were not significant, possibly because they have a lot of variability. Puddle 2 had no mosquitoes. Water quality was analyzed only to compare quality with mosquito puddles. Puddle 5 was exceptional. It was the only one where we found other microinvertebrates, and the water quality was better than in other puddles. But there were fewer mosquitoes. The mosquito larvae was only found in puddles. A greater diversity of aquatic macroinvertebrates was found in the river. In Puddle 5, exceptionally, few mosquitoes and other microinvertebrates, mainly gastropods, were found. Okay, so in this slide, cluster analysis allows you to compare all sampling sites and all variables, setting similarities when grouped at a shorter distance forming a cluster, and differences when chaining distances are greater. In river sites 1, 5, and 2, and 3 form a cluster by similarities in water quality values, macroinvertebrate type, and land cover. Site 4 of the river is located after sewage discharge and has high levels of alkalinity and conductivity, low diversity of macroinvertebrates with predominance of gastropods. Puddle 2 had water connection to the river and had no mosquitoes. Its water quality is intermediate between the river and the puddles with mosquitoes. Puddle 5 with few mosquitoes was also atypical. It had no turbidity and alkalinity and conductivity values were lower than in the rest of the puddles with mosquitoes. In this puddle, there is the only one found to be more diverse in macroinvertebrates. In the analysis of variables, temperature, pH, dissolved oxygen, and nitrates have similarities. Alkalinity, turbidity, and conductivity have greater diversity of values. Macroinvertebrates have similarities to each other except for mosquitoes with a lot of variation between puddles. Land cover forms two clusters of similarities, one with the coverage of the puddles and the other one with the coverage of the river. The behavior of the canopy variable is different from the two groupings. So in conclusion, in the northern Patagonia region, the rains are concentrated in autumn and winter. In the spring they begin to decline and the summer is dry. In the mosquito breeding season, the temperature rises and the soil moisture declines. The flow of the Chimui River decreases throughout the summer, reaching its minimums in the early autumn and leaving temporary puddles on its banks, which some are chosen by the females to lay their eggs. Mosquito puddles in general are characterized by being closed, ephemeral, with high turbidity, alkalinity, and conductivity. The dissolved oxygen content is very low. In puddles with a current of water, even if they are small, they do not have mosquitoes, and their alkalinity, turbidity, and conductivity are slightly lower than in mosquito puddles. The quality of the water in Chimehuin River is better than in the puddles. Macroinvertebrate diversity is greater in the river than in the puddles. In puddles with mosquito larvae, generally only amphipods were found. Female culeate mosquitoes would be choosing critical environments for other macroinvertebrates that could prey on them. It is recommended to carry out a greater number of investigations of the species and habitats of mosquitoes in Patagonia. Knowing the characteristics of habitats can be useful to design larval control systems and mitigate the effects of mosquito movements due to climate change to areas that are now extreme for their development.
Thanks for your attention.